we are going to solve a high-value Cambridge IGCSE physics calculation faster than the average student even finishes reading the question. Seriously, look, we've all been there, right? Staring at a paper, completely freezing up, and just feeling those seconds tick away. But if you want to stop bleeding marks and start reverse engineering the exact answers examiners are practically begging to see, well, you're in the right place. Today, we are completely bypassing ordinary, boring textbook revision. We're going to focus exclusively on the mechanics of top-band answers. Take this classic London bus pressure question. It gives you a mass of 1.4 times 10 to the power of 4 kilograms and a contact area of 1,490 square centimeters. Now, the stakes here are incredibly high. Students lose crucial exam marks and precious time right here because of a massive hidden trap in the data. You know what happens? They see the numbers, they plug them straight into the equation, and they completely fail to realize they've just sacrificed the whole grade boundary before they even reach the final answer. Okay, let's dive into exactly where things go wrong. A flawed, painful learner mistake happens when a student calculates the weight, divides it by 1490, and just moves on. They miss the crucial unit conversion, and they completely ignore the significant figures requirement. But contrast that with a true top-band answer. Notice the specific, deliberate conversion from square centimeters to square meters. You have to divide by 10,000, not just 100. Then, that final answer is locked in at exactly 2 significant figures. This shows exactly where ordinary revision fails, because memorizing the formula just isn't enough when the examiner is actually testing your attention to detail.
And honestly, this brilliantly illustrates a much larger reality about this paper. Students generally don't fail because they don't know the physics. Nope, they bleed marks by ignoring specific command word fulfillments and final answer checks. Examiners are literally forced to penalize you for missing units, for rounding your numbers way too early in a multi-step calculation, providing vague explanations when a specific law is required, or just writing really weak practical improvements. Listen, examiners aren't being mean, they are testing your scientific rigor. If you aren't actively checking for these 4 specific pitfalls, you are simply leaving easy marks on the table.
So to beat this, you need an elite framework. Here are the 4 steps top candidates use to dissect any mass, weight, density, or pressure question without breaking a sweat. Step 1, identify the core concept. Like, what physics principle is actually being tested here? Step 2, pull the exact evidence or data from the prompt. Step 3, apply your scientific reasoning to link that data right back to the concept. And finally, step 4, package it perfectly using examiner wording. When you apply this exact sequence, the exam transforms from a panicked rush into a simple game of spot the error.
Let's actually apply the first 2 steps of our framework to that bus data we just looked at. Our variable for mass is ready to go in kilograms. Perfect. Gravity is locked in at 9.8 meters per second squared. Also perfect. But the area? That is flashing red. 1490 square centimeters is your massive spot the error moment. To get pressure in pascals, your area absolutely must be in square meters. So, remembering that there are 10,000 square centimeters in a square meter, we divide 1490 by 10,000. That gives us 0.149 square meters. Boom. That single careful observation secures your method marks before you even touch a calculator.
So the crucial point here is the final execution. The pressure calculation yields 920,000 pascals. Now, what's really interesting about this isn't just the math, it's the formatting. The prompt explicitly demanded the answer to 2 significant figures, the 9 and the 2. The rest, they are just placeholder zeros. If you write 920,805 simply because that's what your calculator spit out, you lose the final accuracy mark. The examiner is checking your understanding of precision just as much as your ability to multiply. You've got to give the examiner exactly what they ask for. No more, no less.
In just a moment, I'm going to show you the exact examiner clue that changes the answer completely for our next problem. But first, you really need the framework that makes that clue obvious, starting with this quote. Missing this exact examiner clue makes a perfectly executed calculation totally worthless. You must state the key definition, law, model, method, or equation using the correct physics terminology. Stick around because seeing how this specific rule applies changes everything about how you approach distance estimation on this paper. It's literally the difference between an A star and a B.
All right, let's shift our focus to the aeroplane estimation problem. We are escalating the stakes here with a much harder example. So, an airplane flies at 840 kilometers per hour, taking 17 hours and 22 minutes to get from New York to Singapore. You are asked to estimate the distance without using a calculator. For a lot of students, this is the exact moment the panic sets in. You've got awkward numbers, a time format that isn't cleanly decimal, and your main tool, your calculator, has just been taken away.
I want you to pause the explainer and predict right now, where is the fatal anomaly in this distance calculation? Seriously, take a few seconds to think it through. How would you realistically handle 17 hours and 22 minutes multiplied by 840 kilometers per hour, especially when the command word clearly strips away your right to use a calculator? Think about your very first step before you even attempt the math.
Okay, if your first instinct was to convert 22 minutes into exact decimals, like 17.36 hours, you've fallen straight into the trap. Students get entirely bogged down trying to be perfectly accurate here. They start attempting long multiplication with decimals on the side of the page. But remember the command word, it's estimate. Attempting complex multiplication with decimals without a calculator is a massive waste of time and it's highly prone to error. You have to adjust your strategy to match the command word, simplifying the numbers so you can actually process them mentally.
Here's exactly how the examiner mark scheme rewards you for this specific question. You get 1 method mark just for stating or using the core equation, distance equals speed multiplied by time. You get a second method mark for sensible time rounding, meaning rounding 17 hours and 22 minutes to something highly manageable, like exactly 17 hours or maybe 17.5 hours. Then, the final mark is reserved for approximate multiplication, giving an answer safely around 14,000 or 15,000 kilometers. See? The mark scheme rewards the estimation reasoning and your physics intuition, not exact decimal precision.
Let's recap our core framework with the ultimate final exam check. Every single time you finish a calculation, you need to make it a habit to ask yourself, are the units actually present and correct? Did I remember to convert those tricky centimeters to meters? Do the significant figures exactly match what the prompt asked for? Are my scientific conclusions fully supported by the evidence I just calculated? And crucially, is the final answer physically reasonable for the context? This checklist applies to resultant force and density questions just as much as it does to pressure and speed.
So you have mastered the mechanics of these calculations today. You know exactly how to spot the unit traps, how to format your significant figures, and how to confidently handle estimation command words without panicking. But what about graph axis errors and weak practical improvements? Those are the specific areas where the highest grade boundaries are decided, and right now, you are still totally vulnerable to losing massive points on practical investigation questions.
Are you really willing to let a simple graph axis error cost you your top-tier grade after nailing all the hard calculations? No way. To close this gap and speedrun the absolute hardest practical skills on the paper, you must move to our next explainer right now. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations.